Hello everyone, welcome back. Today we've got a pretty interesting project. It's not RV related specifically like normal, but it is RV adjacent, both literally and figuratively. We are going to be working on our golf cart. Here in Florida, we do have a golf cart. We recently bought this little thing because we are in a golf cart community and it is very convenient to be able to get around. I originally thought when we bought this thing that I could just deal with the lead acid batteries that came with it because they were brand new, but very quickly into owning it, I realized they are still terrible for a number of reasons that I'll talk about later. So we're going to be replacing them with lithium batteries, but we're going to take it one step further and we're going to try to add some solar panels to the top of this golf cart. So it is going to be very similar to the power systems that we have put into RVs, but in a golf cart. Very interested to see how this turns out. I'm not exactly sure how it's going to go, but it should be a pretty do-it-yourself project. So if you're interested in doing the same thing, this should be very doable. Let's get into it. So we'll talk about parts, pieces, and installation and why as we go through the install. But the very first thing I want to do is I want to benchmark how this cart performs with the lead acid batteries that are in it already. So what I originally did is I installed this little battery meter. It's extremely simple. It's just a shunt-based battery meter. And this is the first thing I always recommend that you do with any power system build is install a high accuracy shunt-based, which means it goes inline battery meter to really give you accurate information about how the batteries are performing. What I want to do is I'm going to take this out for a drive. We're going to take a look at what this battery meter says. This really isn't specific to lead acid batteries, but it will work. It'll give us, what I'm going to look for is just current and power, and we're going to see how they perform, because one of the things about these batteries is that they work really well for the first couple miles and then immediately start to tail off, and that's just pretty normal for lead acid batteries, and then they operate at a kind of a lower state for a long time. So I'm very interested to see what kind of peak performance we get out of this thing. Let's take it for a drive. So you see a peak of about 137 amps, about 5 kilowatts, and then it starts to kind of tail off. Now we're gonna go see what kind of top speed we get, and I'm not really expecting increases in speed necessarily because the motor controller is actually going to dictate that. But the voltage current relationship, it might still push a little bit more power. So let's see what kind of speeds we get and what it draws at top speed. Because we're also going to be lightening this cart up a lot, so that might change it. All right, so we got kind of our batteries full, acceleration, top speed. I'm gonna drive this thing for about 6 to 7 miles, and then we're gonna kind of retake these readings. It really is good to have this battery meter in place ahead of time for us. Also, is looking at that peak current, because if you're gonna be putting lithium batteries in, they're gonna have BMS, battery management systems on board, and they're gonna have current limits, like how much current they can actually put out. If your cart is gonna draw more than the batteries you're choosing, then you're gonna trip those batteries off. So it's really important to know how much current your cart draws. You could do this with just a simple meter, but like a handheld meter, but you could also install this ahead of time because you're gonna want this when you do the upgrade anyway. All right, so we've now got about 7.5 miles on the cart. We're gonna retest the full acceleration and top speed. Batteries are at 48 volts setting. So here we go. Still seeing a top current of about 130 amps, so that didn't really change. Voltage dropped to about 40 volts. I don't remember what it was before. I think it was about 44, so we're about 4 volts lower, and the maximum output was only like 4.5, about 1,000 watts lower maximum output to the motor under heavy acceleration. I don't think top speed is really any different at this point though, because it's still easily able to meet that current requirements, and that really hasn't changed. So like I said, these batteries are pretty much brand new, and really this is best case scenario. I'm just gonna jot these numbers down so we can compare them once we switch them. I'm really excited. Let's get started on this project. The very first thing we got to do here is start taking the batteries out. When you break the circuit, make sure it's in, so in tow mode in this case, it's keys off. There's no power going to the cart. I like to break the circuit somewhere in the middle because these are usually in series. There we go. Okay, so now the circuit's broken. There's no way that we could accidentally short across the cart's frame or anything, although everything's plastic, so it's relatively safe. These batteries have been so problematic with regard to the amount of off-gassing, corrosion they cause, and dripping of acid. The final straw was that we put in a brand new patio here, and every time we charge these when they're a little bit lower, they bubble enough that they kind of create a little bit of a, you can almost see it right now. You get a little bit of wetness on the top of the batteries, and you get a little bit of acid in here. And then when it rains, if we get any water in here, it drips the acid out, and we get acid stains and corrosion on the frame of this cart. And this is extremely common. As we go around, there's thousands of carts here, and so many of the homes where the carts park have bad acid stains and corrosion in front of their houses. So that's really one of my biggest dislikes of the lead acid batteries. The other thing that I absolutely hate is that they're just dangerous. If you were to short out, if you were to have, you know, a wrench fall across both these terminals, it could be catastrophic. It could melt down. It could cause a lot of damage. That's another reason that we're getting rid of these. And also just their performance. They've really been doing okay because they're new, but you give them a couple years and you'll see that the lithiums that we're going to be putting in should really be like a lifetime battery. Like, this cart should really never need new batteries again, which is just kind of a cool thing. Now this is the shunt with the battery meter that I just temporarily put in here. So we're gonna go ahead and just remove all this stuff. As you see, I'm wearing gloves. You do not wanna be getting any of these acids. I've got a lot of little acid burns from messing with these things in the past. I'm gonna put on a long sleeve and even goggles to actually remove these, because these are flooded. You can open these and see the water. And that's another thing, you gotta maintain these, right? You gotta keep all these cells to the appropriate water level. It's just not a great battery. We've also noticed these batteries discharge significantly just sitting for like a week and a half, and we see a significant drain. With the lithiums, that shouldn't be the case. We leave for 6-9 months, and we want the batteries to be able to sit and not go dead, because that's really bad for them. Another thing with these batteries is that if you want lead acid batteries to last the longest, you really need to recharge them immediately after using them. You should never let a golf cart sit partially discharged for any length of time. All right, here we go. Again, working with batteries, gloves, long sleeves, goggles. I actually worked with lead acid batteries in industry in the past, and I had to wear an entire acid suit just to go near them. It can be crazy dangerous. You do not want to get this stuff splashed in your eyes or anything. So here we go. Oh my gosh. Oh yeah, another big benefit. These things weigh so much compared to the new ones. I'm going to weigh the difference and we'll see how much lighter we're going to be. Oh my gosh. How am I going to get these out of here? Oh, golly. Oh my gosh, you're going to have to see this. There's so much corrosion in here from the acid leaking that the terminal post that held it down has completely been eaten away. Oh gosh. Look at this. See this post here? See how much etching there is on there? That's what holds the batteries down. It's completely eaten away on this side, and the corrosion is just awful. Here's some corrosion from wires. Wow, we're gonna get all this cleaned up and we'll never have corrosion again. So you can see the batteries we're replacing them with are significantly smaller and lighter. We went with a 75 amp hour battery because we just didn't feel that we needed the massive capacity. You can drain these pretty much all the way down. So we're gonna be able to get mileage all the way to the bottom, where these you can only get about 50% of their capacity. What I'm really curious about right now is what the weight difference is. This battery weighs in at 26.7 pounds. This battery weighs in at 83.8 pounds. Wow, we're gonna drop 228 pounds going to these batteries. That alone will actually give us more range and efficiency, so you don't need as much battery. So there's just so many reasons that going to a lithium is so much better. I'll talk about why these particular batteries in a little bit, but let's keep on getting rid of the rest of these and clean that place up. All right, let's now see if we can get as much of this corrosion out of here as possible. No sense in putting nice clean batteries that won't corrode in an old nasty spot. All right, pretty well cleaned up. Look at this. The battery hold downs were so corroded they just broke out when I was cleaning this. Ugh. And sadly, there's probably a lot of lead that I washed out in there. These things are just toxic. Now that we have a nice clean compartment, we're into the test fitting stage, and look how little these guys are compared to what was there. Now this is great because we actually need to put some more things in. First of all, we need to put a charger in, all right? This is the charger that we're gonna be using. It's a Form 15 amp, 48 volt charger, and I think I'm actually just gonna sit it on top of the battery there. We got plenty of clearance under the seat. We'll probably strap that down. Another thing that we're gonna be adding is this thing. So the existing charging port was this special plug for the charger that came with the cart, but I'm gonna be replacing it with this plug so that all we use is an extension cord. We won't have to use the external charger anymore. The charger will be on board. So this will actually plug in to the back side of this. It's just a little extension cord. So I'm gonna pop that out and replace it with this. Now the drawback to doing this is that there's a disable relay in here, so it will disable it from moving when the key is on when the charger's plugged in. So if there's an extension cord plugged in, technically you could drive away with it. That's definitely a drawback to doing this, but I think overall this is gonna be a far more appealing option. We also need to add our shunt, what we put in before. This is the battery meter. It's gonna be critical that all the power from the negative side of the batteries goes through this. So that's going to mount, I don't know, somewhere in here. Need to figure that out. And then lastly, we're gonna be adding solar to the cart, right? So we got, oh geez, a little solar charge controller that needs to find a spot in here. Maybe we can fit it on the wall, or yeah, maybe it'll fit in there. I'm not sure. Of course, we have a plastic cover to cover all this stuff and keep it dry. But that's what's next. I'm gonna start tearing this down. Also need to remove this floor plate so we can run the wire for the battery monitor, put it up on the dash somewhere. So if it looks like I know what I'm doing with regards to taking apart this cart, that's great, because I really don't. They're pretty simple machines though. Right now I'm just trying to find a place to mount the battery monitor. I'm thinking right there would be great if there's not too much underneath there. You can really just take them apart. You could probably get a manual for it if you really want to know which screws to take out. I'd say the only thing is if you got these plastic tools, this plastic tool remover thing, if you got those little plastic clips, that makes it a lot easier. Other than that though, I mean, we just take it apart. I found a nice run for the wire underneath the floor mat, up into here. We're gonna see if we can get it up in here. All right, that took way longer than I would have liked, but we got the battery monitor and the cable run underneath the floor. We also got our new 120 volt plug installed and put the cart all back together. Figuring out how to take the cart apart was one of the hardest things, but now we get to the meat of the potatoes of this. Let's put the batteries in and figure out where everything's gonna go. So you may be asking, why Battleborn batteries? The reason is primarily that I've been using these batteries for years, and in the lithium game, I'm all about safety and longevity. Battleborn uses a cylindrical cell, which has a little bit more safety to it, better heat dissipation, especially in a higher current application like this, than prismatic cells. They also are an American company. They've been assembling them in Reno. I've actually done a lot of work with them at their factory, and just really like their product. I've used probably a dozen of their batteries on all sorts of different projects, and I've never had a problem with one. Now, golf carts is not really their specialty. This really isn't the application for these batteries, but these are group 24 batteries. They're a little bit smaller, 75 amp hour. I really just didn't need 100 amp hour batteries. They do have a 100 amp BMS though, that can peak to 200 for 30 seconds. So it should easily be able to run this cart. But there is one trick with using lithium batteries, is that you really have to have a pre-charge resistor that short circuits the relay that turns on the motor controller, and that's right here. And this cart already had it, it came with it. But if your cart doesn't have it, you want to use lithium, look up pre-charge resistors and figure out the one for 48 volts, 36 volts, whatever it is. This is really important to have because the capacitors in here, when they click on, they can actually trick these batteries into thinking there's an overcurrent situation, and the protection inside these batteries will shut them off, and then you have to disconnect the system to get them to come back on. Hopefully we don't have any problems, but we're gonna find out if this is the right way to go. Now I gotta figure out where this battery monitor is gonna go. So this is our primary negative terminal, and then we're gonna have this all in series. So the primary negative terminal needs to come to this, and then from this, we need to have another little chunk to here. Maybe I should flip this battery around. So then we're gonna go positive to negative to negative. Probably should flip this one, and then positive to negative. So we're creating a 48 volt system. That's kind of what we're doing here. Now we just got to figure out where everything's going to go. This is your shunt. So all the power flows through these little bars here, and then it takes a battery reading from the other side of the battery. So it's going to have negative, and then this needs to go to the most positive terminal, which will be over here. And that's going to give it its voltage reading. And then this, all the current flows through it, and it gets a high accuracy current reading. And that's how we get the high accuracy battery reading from it. So highly recommend you having a good shunt battery meter with really any battery system. I think the MPPT will go somewhere in here as well. Charger over there. I think it's a matter of just putting it together now. One more thing I am going to add is a 48 volt to 12 volt regulator for the low voltage system. And this is the lighting and any other 12 volts on the cart. Now previously, you'll see this blue wire here. This connected to the positive terminal on this battery over here. And then the other side of that was this right here. The negative comes right off the negative, which is this wire here. So basically it was doing was pulling 12 volts off one battery. It works to get you 12 volts, but you don't want to do that because you misbalance the batteries then. I never ever recommend doing that. Better with a lead acid system because they kind of balance, but especially with lithium, you really don't want to do that. You want to be running a 36/48 volts to 12 volts to make sure that you're getting a, first of all, steady 12 volts to the system, and you're not unbalancing the system. So this is actually going to take the 36/48 volt input. So these two, I need to connect them to leads. One of them is going to go to the most positive and most negative terminal on the 48 volt system. And then this is our 12 volts. So then we're going to tap this into this, basically this wire here will get tapped to the positive, and then this will get tapped to the negative. And it's all grounded. So it doesn't, I don't know, it might not even need that one, to be honest, but I'm not sure. It's probably an isolated system, so it probably does need it. All right, that's what we're doing. Let's get to it.
So how's it coming?
Oh, my back. I'm at the mess stage, as you can tell. I feel like I've gotten all my tools out. Right now we are we're doing detail work, right? So this is the 12 volt converter. I had to solder all the wires up, the positive and negative. So here's our 48 volt positive, 48 volt negative. What you have to know when you're putting a battery meter in like this with a shunt is all of your power has to go through that shunt. All the power basically between the battery and the cart, and that includes your charger. So this can't land directly on the battery. It has to land on the cart side of the shunt, and that is going to force all of the charge through that shunt too. So we can actually get both sides, positive and negative. Otherwise you'll just get discharge and it'll just keep reading more and more negative. This is the 12 volt. So it'll measure how much power's the little converter's drawing, but I'm also landing our charger, which is right here. Just everything's just set in place right now. So positive side of the charger will go to the most positive battery terminal, but the negative side, which is this right here, is gonna land on that battery meter. Yeah, you can't even see it in there. So basically everything's 12 volt converter, and the power is all gonna land on this side. It'll all go through here and then up to the most negative terminal. You don't want to put power to anything until you've got everything all wired, because you don't want to be working with the higher voltage. So we're almost there where we can actually hook up these batteries. Well, I'm whooped. We are so close to be able to hook this up, but I'm losing my light, so we're gonna have to get back at this tomorrow. We're so close. All right, I got up early this morning, excited to try this out. We got it all hooked up finally, got the floor mat back in. I've slowly tested everything by just hooking it up and seeing 12 volts works, charger works. Let's see how she goes. Wow. Did you see that? Wow. Whoa. That is noticeably better acceleration. Over 6,000 watts, 6.8 I saw. That's almost 2,000 watts more acceleration. This car it's a whole nother animal. Wow. We hit 19.6 miles per hour, which is more than 2 miles per hour faster than before. It has a 19 mile per hour speed code on it, so it really should limit it at 19 miles per hour, but just never reached it before. Now it's reaching its top speed. The acceleration and the additional power is because of the voltage. The voltage, even at full acceleration, is dropping to like 49, 50, but the same current. So hence we're getting a lot more power, much faster on acceleration. It's also, the most noticeable thing is actually how much more nimble it is. With 220 less pounds, it feels like I've got one less person on it. It's as if I'm not even on it compared to before. It's so light and nimble, and that just helps improve its speed as well. So overall, absolutely incredible difference just with the batteries. Now, let's see if we can install some of these solar panels. All right, so let's get the solar side of the cart started. What we're using here are 25 watt panels. These are just little panels. You could go a lot bigger. You can go pretty much as big as you want with solar, but we're just gonna kind of try trickle charging it. And I wanted it to be simple and really fit within the roof for this cart. So these panels are 22 volts open circuit. And the reason we got 4 of them is we're gonna put them in series, and we're gonna have a nice high voltage, way higher than the batteries, that then the MPPT charger, charge controller, and maximum power point tracking charge controller we're gonna install down in the battery compartment will modulate this power to really maximize its output into the batteries. Because we're gonna be talking 80, 90 volts, we can go really small wire. This is the wire we're gonna use for actually taking it down to the batteries. For the connections, we're gonna use these little tiny solder / waterproof connectors, and then we'll wrap it all up. So we're gonna actually wire everything together permanently, but I will use an MC4 connector so that we can actually disable the array or disconnect the array from the batteries if needed. For mounting, I'm just gonna try some extreme outdoor Velcro out of curiosity. I've never used this before. I would use this, but this is extremely expensive and I wanna save this. This is one of my favorite mounting tapes. This is 3M Extreme Seal. I believe it's 4411G maybe, I don't specifically remember. This stuff is amazing. It's kind of like a Turnabond, except it's not gooey. It'll actually stay kind of a single piece. You can remove it in the future, but it's also extremely good at sealing. I highly, highly recommend using this stuff, but it's also extremely expensive. We're talking like 80 bucks a roll. I've used it though on solar installs, taped panels down. I've had this stuff on the roof for 4 years now with absolutely no degradation. Really good UV resistance, great, great stuff. I'll probably use a little bit of this to tape some of those wires down. Anyway, that's what we're gonna be doing. While I'm doing the soldering, I am also going to be just covering the panels I'm working with because that'll minimize the voltage. We're gonna be working with pretty high voltages on these panels. So if you do a serious situation, keep in mind that the voltages could get pretty high and could pose a shock hazard. That's important to note, and one of the reasons we're gonna have the connectors up here so that we can disconnect these panels so that when I'm working with 80, 90 volts at the charge controller down underneath, we can have it disconnected, and then finally to power the system, click, it'll fire up. All right, let me show you what we got going on here. So all the panels are in series with each other now. So these are the solder things I was talking about before. See, these are a waterproof connection, but they've got a little piece of solder in them that melts under the heat gun, and it makes a really great connection. I tested our output here, and we've got 90 point some volts coming off of here, so that's perfect, exactly what we wanted. Now I'm just going to tape up these and then kind of mount these down a little bit. We'll mount the panels down with some of that Velcro, and then we'll add the MC4 connectors onto these wires here, and we'll run the wires down to the batteries. We've got this thing hooked up, battery side and solar side. I just tapped into the circuit with the inline fuse for our controller. So pretty straightforward. Now we just got to hook up these panels on the roof and that thing should light up. All right, it's working. We got a little blue light on here. And our charge controller says 2 watts. It's partially cloudy right now and we're late in the day, so I am pretty happy with that. It's coming in around 60-70 volts for the actual charge, and then we're seeing about 0.5 amps right now. But even 0.5 amps is 35 watts, so pretty cool. Well, that was a bigger project than I think I expected, but it is, I would say it's do-it-yourself. It's really kind of just assembling the components. You do need to have some electrical knowledge, especially if you're gonna be working with the higher voltages like this, so you don't get hurt. But overall, it was actually a really fun project. I think we're gonna spend some time just using it over the next couple days, and we'll come back with the conclusion, let you know kind of how it's working. What do you think, hon?
Well, I think it actually took you longer to like disassemble the pieces of the car. Yeah, than actually put it together. And honestly, he's been kind of enjoying working outside because we have a lovely day. But it took a little longer, but yeah, it was
Excited?
I'm so excited. I'm so excited.
All right, it's been a week since we installed the lithium and the solar on this cart, and we have used it a lot. We had family visiting, and this cart got used every single day, back and forth between a couple different places. It's probably done about 70, 80 miles so far. We've got a pretty good idea of how it's been performing. Let's start with the solar panels. The solar panels have been making about 300 to 500 watt hours per day. I think it made almost 600 one day, but we haven't had full sun. The 600 watt hours was a mostly sunny day. So that is giving us about 4 to 6 miles of range per day. On a partially cloudy day, that's closer to like 3 miles. The cart tends to get about 130 watt hours per mile. That's how much energy it burns with just the 2 people. But when we load it with 4, which we did a lot this past week, it burns a lot more, closer to like 200 watt hours per mile. That seems pretty good, but compared to efficient electric cars, it's not really that great. But it's a golf cart. What can I expect? As for the lithium batteries, incredible. Just so much better overall. With 4 people on board, it didn't bog down near as much. We've driven it down to, well, really only in like the 50% state of charge, because that solar has been just kind of keeping it up. But even at that rate of charge, or that state of batteries, it still just feels so much better. Acceleration is so much better, and just being lighter, just a game changer overall. No more worry about the acid, no worry about charging it. The plug-in 120 volt charging, so much better. Overall, everything we've done to it, I absolutely love, and I highly recommend these upgrades. If you're curious to learn more about why we use the Battle Born batteries, head over to our website. We wrote an article all about why we use Battle Born batteries. Just do a search for it. We've got tons and tons of other information about solar power systems over there. If you want to figure out how to size your solar system correctly for what you need, we wrote a whole article all about that. The little solar system we have on here, no, it's obviously not enough to do everything we want to do, but it's just because we have a little bit of space. Why not? If you really want enough solar on a cart, you're probably going to have to go with 2 to 300 watts, maybe even a little bit more if that you want that to be your primary energy source. But that's not the goal with this cart. If you really want to figure it out, you can do a lot of math ahead of time to really understand how much energy you need for your RV or even your house. Over on our website, we have a calculator all about that. As always, thank you so much for joining us here on Morton's on the Move and some of our crazy projects. We are going to be back on the road, having some adventures soon. So lots more travel content coming at you. As always, safe travels. We'll see you down the road.